Welcome everyone! Today, we're unmasking the top 7 unexplained mysteries of quantum physics that'll leave you with more questions than answers. Hi Ed lovers, Jay here, and welcome to EdPOP, your go-to channel for the best science facts and curiosities you can't find anywhere else. But before we get started, be sure to subscribe and turn on the notifications so you never miss a new video. Alright, let's dive in. Number 7. The measurement problem. Now, onto the mysteries that make quantum physics the strange and incredible field it is. Diving into the intricacies of quantum physics, we land on a fascinating enigma at spot number 7, the measurement problem. This puzzling issue arises due to a peculiar characteristic of quantum particles, which exist in multiple states until measured. The measurement problem stems from an observation within quantum physics that a quantum system remains in a superposition of states until a measurement is made. At that point, the system collapses into one particular state. The conundrum is, why does the act of measurement or observation cause this abrupt transition from multiple possibilities to a singular reality? This phenomenon seems absurd compared to our everyday experience. It's as if a football could be in multiple places at once until a player decides to kick it, and only then does it settle in one location. The measurement problem is not just perplexing, it shakes the foundation of our understanding of the universe. It even had the brilliant Richard Feynman, a Nobel laureate, admitting, "I think I can safely say that nobody understands quantum mechanics." Number 6. Quantum teleportation. Diving deeper into our journey, mystery number 6 takes us to the realm of quantum teleportation. Now, if you're imagining Star Trek's Scotty beaming people up, it's a bit different, but no less intriguing. Quantum teleportation, at its core, involves transferring the state of a quantum particle from one location to another, without any physical travel of the particle itself. It's a concept that has perplexed and fascinated scientists since its theoretical introduction in the 1990s. But hold on to your hats, because this isn't just theoretical anymore. Research teams around the world have been experimenting with quantum teleportation, managing to teleport particles like photons over significant distances. This could revolutionize communication, potentially leading to quantum internet. Secure and fast, surpassing anything we have today. But much about quantum teleportation remains unclear. How do we scale this up from photons to larger particles, let alone humans? What about the loss of the original particle's state once it's teleported? As you can see, the realm of quantum teleportation is fascinating and full of unanswered questions. It's a mystery that continues to challenge the boundaries of our understanding. Number 5. Quantum Zeno effect. Journeying further, we arrive at mystery number 5, the quantum Zeno effect. Don't be fooled by the name, this isn't about ancient Greek philosophy, but it does have a certain philosophical twist to it. The quantum Zeno effect is a strange phenomenon where, essentially, an unstable particle, if observed continuously, will never decay. Yes, you heard that right. Never decay. Just like Zeno's paradox, where Achilles never overtakes the tortoise, a quantum system seems to freeze while being observed. It's like a watched pot never boils. Only in this case, the pot is a quantum particle, and the watcher is an observer making measurements. It's as though the very act of observation is holding the particle in place. The philosophical implications of this effect are profound. If our observation can influence the behavior of a particle, then what does that tell us about the nature of reality itself? Do we, as observers, have an active role in shaping the world at the quantum level? Or is it all an illusion born of our incomplete understanding? It's questions like these that make the quantum Zeno effect one of the most mind-boggling mysteries in quantum physics, leaving scientists both thrilled and perplexed. Number 4. Quantum tunneling. Descending further into the realm of the quantum, we reach mystery number 4, quantum tunneling. This isn't about digging tunnels in the traditional sense, but rather it's about how particles can, well, cheat their way through barriers. Quantum tunneling is an utterly bizarre yet fundamental aspect of quantum mechanics. Imagine throwing a ball at a wall, expecting it to bounce back, but instead, it appears on the other side of the wall, seemingly breaking all the rules of classical physics. In the quantum world, particles like electrons do this all the time. Here's where it gets even more paradoxical. This isn't just a theoretical concept. It has practical applications. In fact, you're using a device right now that relies on quantum tunneling. Yes, I'm talking about your computer or smartphone, which uses tunnel diodes and scanning tunneling microscopes. Yet, despite this practical application, quantum tunneling remains shrouded in mystery. How can a particle know it can tunnel through a barrier? Why does it defy the well-established laws of classical physics? And how does this happen instantaneously, defying the very concept of time? These unanswered questions make quantum tunneling one of the most intriguing mysteries of quantum physics, reminding us how much of the quantum world still eludes our understanding, even as we utilize its paradoxical phenomena in our everyday technologies. Hey, wait! Now's the time! Subscribe to the channel to be entertained while learning. It's free! Number 3. Wave-particle duality. As we break into the top 3, we find ourselves face to face with number 3, wave-particle duality. Brace yourselves, because this one has puzzled some of the greatest minds in physics. In the everyday world, things are typically what they appear to be. A cat is a cat, a dog is a dog, right? But quantum mechanics plays by a different set of rules. In the quantum realm, particles can be both particles and waves. It's as if a cat could also be a dog at the same time. Yes, it's mind-bending, but that's the essence of wave-particle duality. The famous double-slit experiment encapsulates this mystery. In the experiment, when particles such as light or electrons are fired at a barrier with 2 slits, they don't just pass through one slit or the other like traditional particles. Instead, they behave as though they are waves, creating an interference pattern on the screen behind the slits. But here's where it gets weirder. Even if you send the particles through one at a time, you still get an interference pattern. This suggests that each particle, in some sense, goes through both slits simultaneously and interferes with itself. What does this mean? How can something be both a particle and a wave at the same time? And why do particles seemingly change their behavior based on whether they're observed or not? These mind-boggling questions make wave-particle duality a tantalizing mystery that continues to defy our conventional understanding of reality. Number 2. Quantum entanglement. Mystery number 2 is the fascinating world of quantum entanglement. This is one of those phenomena that seem too strange to believe, yet it's part of our quantum reality. Quantum entanglement refers to a phenomenally intriguing yet mysterious correlation that exists between pairs or groups of particles. In this quantum connection, the state of one particle is instantaneously related to the state of the other, no matter the distance between them. It's as if they're 2 pieces of the same whole. To give you an analogy, imagine having 2 dice, and no matter how far apart you roll them, they always show the same result. Now, imagine those dice aren't just across a room, but galaxies apart. This is the spooky action at a distance that Albert Einstein referred to, and he was quite bothered by it. What's truly baffling about this is that these correlations happen instantaneously, seemingly defying the universal speed limit, the speed of light. How do the particles send these messages faster than light? Does this mean they're somehow connected through an unseen, faster-than-light medium? Or is there something fundamentally wrong with our understanding of space and time? These are questions we don't yet have answers for, which is why quantum entanglement holds such a high spot on our list of quantum mysteries. It's a perplexing phenomenon that challenges our most fundamental understanding of how the universe should work. Number 1. Quantum superposition. We've arrived at the number 1 spot on our quantum mystery tour, the concept of quantum superposition. Prepare to have your mind boggled as we step into the land of possibilities. Quantum superposition is a fundamental principle in quantum mechanics, and it tells us that a quantum system, like a particle, can exist in multiple states or places simultaneously until we measure it. Sounds bewildering, right? Well, let me introduce you to a famous thought experiment that might help. Or might make it even more baffling. Schrödinger's cat. In this experiment, proposed by physicist Erwin Schrödinger, a cat is placed in a box with a radioactive atom. If the atom decays, it triggers a device that releases a poison, killing the cat. Now, until we open the box and check, the atom is both decayed and not decayed. Thus, the cat is, in the mind-boggling world of quantum mechanics, both dead and alive at the same time. It's only when we open the box and look that the cat becomes either dead or alive. This idea doesn't sit well with our everyday experiences, does it? We're used to the world being definite, not a smorgasbord of possibilities. Yet, this is exactly what quantum superposition proposes, pushing the boundaries of what we think we know about reality. Why is this so perplexing? Because it seems to suggest that the act of observing or measuring something can fundamentally change its nature, bringing it from a cloud of possibilities into a single reality. But how is this possible? What mechanism is at play? And what does this say about the nature of reality itself? Despite being a core aspect of quantum mechanics with real-life applications, quantum superposition remains one of the most mind-boggling mysteries of quantum physics. Well, there you have it, the top 7 unexplained mysteries of quantum physics. These mysteries continue to baffle and intrigue scientists and thinkers all over the world. Yet, these unexplained phenomena are what makes quantum physics so incredibly exciting. What are your thoughts on these quantum mysteries? Do you have your own theories or insights? We'd love to hear from you, so don't hesitate to leave a comment below. And if you enjoyed this journey into the quantum realm, be sure to hit that subscribe button. We've got plenty more fascinating facts and discoveries about quantum physics and many other scientific topics waiting for you. Stay curious, stay tuned, and always keep wondering, because who knows, you might just be the one to solve the next quantum mystery.